Okay, shout out to my School of Music majors that are in my class that told me I should play Cantaloupe Island in the background while I talk about Mole Island. So, right now, we have another problem, okay? And again, the concept is we have this mole island, all right? In our chemical reaction, we have sulfur plus oxygen making SO2, okay? Sulfur dioxide. All right, so sulfur dioxide, SO2. All right, and so that's our problem that we're dealing with, okay? And then we talk about a reaction and we say it burns 300 kilograms of coal. What the heck is coal? Coal's not even in our formula up here. There's no coal up here. But it says coal is 0.5% sulfur by mass. So that's going to give us sulfur right there. Okay. So then it says how many kilograms of sulfur dioxide are produced. So again, I should underline that in red because sulfur dioxide, that's the first thing you need to do when you do these problems is identify what is it I'm starting with and what is it I need to find, okay? So you want to find kilograms of sulfur dioxide, and we're going to start with this, with S. But we have to figure out S first, okay? And so you have to realize that if we take 300 kilograms of coal, and then for every 100 grams of, it doesn't matter, grams, kilograms, for every 100 kilograms of coal, there's 0.5 kilograms of sulfur. Okay? We could say kilograms. We could say 0.5 grams in 100 grams. Okay? So we could say gram, we could say kilogram. And we can do that because if we convert this to grams and we convert this to grams, we're doing the same thing to both of them, and so in the end our number is going to be exactly the same. So our units, as long as our units are the same order of magnitude, as long as our units are the same, so instead of being grams, now they're kilograms, we're perfectly fine just doing that, okay? The other way to think about it, if you don't want to do dimensional analysis, is just realize 0.5% of something is sulfur. And so what that means is if we just take 300 kilograms of coal times 0.005, that's 0.5, equals grams of S. Okay, so it's 1.5 kilograms of S. All right. So, in any event, we have to first, and I don't know why I did that in red, I'm sorry, because that's not SO2, it's S. But we have to first figure out how much sulfur we have. Okay, let me go back to writing that in black. Okay, so we have 1.5 kilograms of sulfur. Again, we're on a boat out here, right? We're in a mass boat. And we have to ride the boat in to sulfur. We're going to take it over to the SO2, and then we're going to ride the boat off to on a mass boat there. Okay. Hopefully kilograms to grams. So 1 kilogram of sulfur, 1,000 grams of sulfur. Okay, let me back up. One more thing. We have 3 sig figs right here. So oddly enough, our answer is going to have 3. Okay. Gets a little confusing to me. I'd be willing to take 1 as an answer because that only has 1 sig fig. But this one has 3, so that's one we're going to use. So 1.5 kilograms, 1 kilogram, 1,000 grams sulfur. All right, 32.06 grams of sulfur, 1 mole of sulfur. Okay, so we just took the boat. Now we're here, okay? Now we use the equation. So 1 mole of sulfur, 1 mole of SO2. Now for every mole of SO2, there's 64.06 grams. And then for every 1,000 grams of SO2, 1 kilogram of SO2. Okay? Now, you should recognize and see there's 1,000 here, there's 1,000 here. So really we could have just done the problem in kilograms and it would have been okay. But you know, that's a little, it's okay. Don't worry about it. You can just do it. It's 2 extra steps. It's not that hard. It's good practice in case units are in fact different. Sometimes it could be, one could be kilograms, one could be grams, you know, whatever. So our answer then is 3.00 kilograms of SO2. 3 sig figs, that's how much we make. Okay? So again, going from here to here to here to here. The pattern's exactly the same as the last problem. Okay?